Hey there, viewers. Thank you for tuning in to Supermariodiagnostics once again. Today we have Scott Nichols from ADDi. He came down from Missouri, right? He drove down from Missouri, not just for me, he came for a vacation, but reached out to me and said, hey, want to check out this tool? I've actually been eyeballing this tool for some time now, and I've been looking to see when it would finally come out, and it did. So he's going to give us a full demo. We got a BMW here, a GDI, and he's going to show us a little bit of the pros and cons of using a Pico versus using the ADDi system with the Pico. I'll let him go ahead and I'll just let him take it over, and I'll be your cameraman.
All right, thanks, Mario. So guys, what the ADDi does is it's actually a hardware filter amplifier. It acts as a radio tuner, and it tunes in on engine and fuel system frequencies. It amplifies those frequencies, and it gets rid of everything else. When you apply that to the high pressure common rail sensor on a gasoline direct inject or a diesel vehicle, it allows you to finally see the actual injector flow rates and the pressure recharges as the high pressure common rail is recharged by your high pressure pump. And when you do that and you connect to your high pressure sensor here, you normally would connect to the low reference, which happens to be our middle wire here, and it's on black. And then we're connected with our blue wire here on our high pressure common rail sensor signal. When you do that, you go to the device here, and actually our blue is a bypass, so you can see the signal without the device up here on the Pico. But you come into the device, all right, and I'm just going to start over. I'm going to turn it off, all right. We're going to turn it on. When it comes on, it starts in what's called tune mode, which is what we talked about. It's the hardware filter amplifier. I normally run at about 2/3 gain. The ADDi's internal hardware amplifiers are fully adjustable. So if you want more gain and you want to see a higher resolution signal, you can turn it up. When you get to a certain point, though, your signal may start to wash. So I try to keep the last yellow or last amber LED on most of the time when I test. So right now we have the green LED, which is tune mode, and the blue LED indicates that we are in what is called zoom mode. So it's zero biased, kind of like an AC couple. Our output is going to go directly to our scope input on our Pico. So we're going to go over here. And this is actually live showing the injector fueling rates of this engine at this time. Notice number one's control hit is right here. We're around number one injector current. You can see the associated flow drop. Right now it looks way better than it did. This car is having some issues with some inconsistency with the injector on number one. I don't even know that it has a symptom necessarily, but as you watch, you'll see that it will go up and down pretty consistently pretty substantially compared with the others. But you can see there's 1, there's 3's flow curve, there's 4, and there's 2. Seems like 4 appears to have more drop here. I honestly think that's probably because the rail recharge is right before it. These up spikes are the actual high pressure common rail recharge events, and notice how high they go, and in response we have probably a little bit deeper drop here because of that higher pressure that it starts at. There are times when doing this testing, a known good is really helpful, and honestly I'd really like to have a known good for this vehicle, which I don't have one. This may or may not be one. It doesn't have any known symptoms that we know of, but this allows you to dynamically, and even on a test drive, see the injector fueling rates. And if you guys have been following along with me in the past, you've seen some of my captures that I've done and shown where I've had a misfire. Recently had a 2018 Ford Edge. If you guys have been following along, you could clearly see that the injector flow rates on cylinder number 3 were substantially less than all the others. And with frequency mode with the ADDi, if you look at that video, I actually was able to show the misfire as it was happening, because you could see the lack in contribution of the crankshaft speed in the crankshaft speed reading. So
right, it's not just for fuel rail pressures, right? We can. What else can we use this ADDi system on? Well,
the most powerful functions of this tool, I find myself using it most of the time for frequency mode, and that you can do it on your Pico with a math channel, obviously. The thing is, and what I run into when I do the Pico math channel, a lot of times I'll have to go in and out of the channel 2 or 3 times to get the upper and lower thresholds right, because you have to get the proper zoom level. A lot of times I have to go back in and adjust the RPMs that my upper and lower thresholds are to get it tight enough that I can see my accelerations and decelerations I want to see. The beauty of the ADDi is it does all that automatically. You literally hook it up to your crank sensor, you turn on the device, you go to mode 4, which is frequency mode, and you hit the auto cal button. It's going to take your signal of your sensor, it's going to calculate the mean or the average, it's going to add 20% and subtract 20% for a 40% zoom window, and then it's going to calibrate the analog output automatically relative to that so that you can see your accelerations and decelerations of your crankshaft with the single push of a button instead of having to go through and set up the actual frequency or crank math channel. It can be done on any scope. It doesn't have to be done on a Pico. I do most of my testing on a Snap-on because, quite frankly, most of the testing that I show with the ADDi isn't possible without it on a Snap-on.
What are we looking at here? We're looking at
generally
drops.
Yes, you're looking at the drops, the drop levels, right? And sometimes more importantly, the angles, okay? And this leads into another one of my tools that I have. It's called ScopeMate. ScopeMate is an overlay that you can use with your scope. It's a documentation toolbox that allows you to actually, right there on the screen without having to go into Paint or anything, it allows you to drag boxes around things, draw highlights, but it has a function for measuring angles in scope captures as well, so that you can relatively compare the drop angles as well as the drop levels.
Now, say one is steep and then another one is a little more of a slope.
Yes.
What are we deducing there?
Well, if you have a flow restriction, typically you're also going to have a shallowing of the slope.
Gotcha.
Most of the time, the slope will have a noticeable. It'll be diminished, not drastically, but it will be measurably different.
So the angle of the drop is proportionate to the flow rate, but the drop itself, the level itself, is the mass of fuel that is being entering the cylinder.
The way this is normally going to present a problem is you're going to have a drop that doesn't drop to near the level of the others, okay? Now, Mario, when we first started taking this capture, remember, we noticed that number 1 had barely any drop at all when this car started cold. Now that this thing's warmed up, I think the fuel is warmer, and I think we're actually getting better action out of this number 1 injector. Maybe that was something with a cold operating strategy. It's hard to say, but when we started doing this, there was a very obvious issue with cylinder number 1, and it only appeared to be cylinder 1. None of the other cylinders really showed any inconsistencies. So if you hook up to your rail pressure sensor on most GDI vehicles, you're going to find it's a very noisy signal. And I started this process originally. I misdiagnosed something, and that's how most, I think, innovation happens, is you screw something up and you try to figure out, well, that was embarrassing. How can we make this better? So when I misdiagnosed this vehicle, I tried to do the Pico WPS injector drop test, but on the low pressure side of a GDI. And I saw something that looked like it made sense, and I put some injectors in, didn't fix anything. It was embarrassing. I'm like, okay, I know we can do a GDI injector drop test the same as we do it with the WPS on the low pressure side. All we need is a window into the high pressure side. Well, we have one. We have a rail pressure sensor. So I went to my rail pressure sensor, tried to AC couple it, and I got something very similar to this that's very noisy. There's not much that's very discernible. You can kind of see some stuff out of it. But notice you really can't get anything defined as far as individual injector events. You can kind of see relative changes to a point, but there's not really any comparative definition that you can make out of it. Now, if you are good with the Pico, and a lot of you guys are, you can mess with the filters and you can get kind of close. It still doesn't tend to get to exactly where I can get. You can turn on the active filtration. You can get some of it. You can kind of get some idea.
Yep.
But notice, I mean, here's an example. I mean, you can see the drops here, they're relatively the same, but look at it here. Okay, it's just kind of an example here.
It's unusable. It's
not really usable. And if any guys that have tried to scope the rail pressure sensor, I think a lot of you guys have run into the same thing. And the ADDi allows you to basically pull out information that's there, but a lot of times the software hides it. A lot of times the hardware or the software filtration will actually make some of this stuff disappear. Whereas when you're using hardware, it's literally passing through exactly what's there and putting it out in your scope and amplifying it. So one of the really powerful features that the ADDi has is it has the ability to give any lab scope a frequency, crankshaft frequency misfire detection. So like you can on your Pico, put a frequency math channel on the crank sensor, well, the ADDi has the ability to internally do that and let any scope do that. All you have to do is connect to your crank sensor. Okay, crank sensor is on the red coming in from our DME. All right, I'm going to go ahead and turn it off and start over. So we're going to turn it on. All right, we're going to go to frequency mode, which is red. We're going to hold the auto cal button. Now, you look up on the screen, you can see your accelerations and deceleration, which is much easier than going in and out of the math channel several times, getting the upper and lower thresholds set to get the proper zoom level so that you can see the small changes in crank speed associated with the misfire.
Not to mention, there's some caveats with the frequency. Like sometimes I use the Pico and I try to use the crank sensor frequency and it just does not come out well. You see a bunch of dropouts too?
Absolutely, and I don't know if you noticed that, but on my ADDi capture, the dropouts aren't there because it's programmed to ignore them. So basically, the dropouts you would typically see are actually there in the sensor. We actually just took a capture of this sensor live, and the dropouts are there, but the ADDi software completely glances over it and ignores them.
So I'm gonna disconnect this coil, and the injector may turn off, but we're gonna watch the screen to show this misfire detection. And there we have a misfire.
And we did find that this BMW fires the injector on the intake stroke. So since we're synced to #1's injector, you can see the misfires 360 degrees of crank rotation out.
Yep, we thought it was...
we thought it fired on compression, and it doesn't.
Yeah, it doesn't on this one. But that's pretty neat. We got to see it clear as day. There are times that the misfire counters are absolute trash. Smoothest operation values, trash. Mode 6 is just not there. I have a car that I'm actually dealing with that's all of the above. No live data, no counts, no mode 6, nothing. So I think this is what I'm gonna have to do.
So we talked about the ADDi in frequency mode for crankshaft misfire detection with crankshaft speed. If you have an NVH probe, and actually I'm working with Joe Casey of Joe's Auto Electric Probes, he's actually making me a custom NVH sensor to be used with the ADDi in order for misfire detection. You simply place your misfire or your NVH probe right on top of your engine, point X forward like you normally would, and we're actually going to connect to the Z-axis on our sensor. The Z-axis gives us our vertical or our lateral deflection from the crankshaft. So when you do that and you pump that through the device, you can actually see, here's our frequency mode and our accelerations and decelerations on our crankshaft, but notice our NVH sensor pumped through the ADDi actually gives us a very similar signal or very similar profile. And if we give this a misfire, you can actually see, there's our frequency mode. You can see the misfire here where it drops off contribution entirely, but you'll notice that the troughs actually come up and the profile flattens slightly. So you can actually see a lack of contribution just by using NVH and not connecting to any sensors on the vehicle, which obviously is quite a bit faster than connecting to sensors and things. Well guys, the last function, or probably the most powerful function of the ADDi, is the J2716 serial data decoder. The J2716 serial data decoder allows you to take a sense signal, it decodes it to binary, and then it generates an analog output that's relative to that binary signal. So if you apply that to a serial data rail pressure sensor like we have on this 2021 Mercedes GLC 300, you'll see that we're connected to our low reference, we're connected to our sense signal, and then the red coming out here is going to the scent decoder. We also have the blue as a bypass so you can see what the signal looks like without the decoder. Here we're going into the device, we're going into the scent decoder. The blue mode is the scent decoder mode, and you can see we're live decoding the J2716 scent signal, and we can see the actual individual injector drops as the injectors are firing on this engine. We don't actually have the injector sync on there anymore, so you can't actually see where #1's injector was, but yeah, it's here somewhere. But here's what the signal actually looks like coming out of the sensor, so when you hook your scope up to it, that's what you're going to see. But we're literally turning that into this, so you can dynamically see the injector flow rates.
Can you clarify, does any other scope decode and provide an analog signal as an output?
As far as I'm aware, my device is the only device anywhere that does what I'm showing here. Obviously, Pico can decode a sent signal. However, it just gives you the hex numbers. It doesn't actually give you any kind of a signal that's useful for relative comparison. The second mode of the ADDi is what I call arbitrary mode. In arbitrary mode, it takes the binary number from the sent signal. It figures, it actually has you exercise the signal or the sensor through its full range, like a throttle position sensor, for example, and then it will calibrate the analog output relative to the min and the max of the signal so that you can see the full range of the signal. Right now, I'm working on a major recode that will allow both sent A and sent B to be output and analyzed, and you will be able to see the full range of both sensors. You'll be able to choose whether you want to see sent A or sent B. I'm actually working on that code right now, getting that working. So yeah, pretty exciting stuff. Yeah, I don't know that there's any other way for this to be done at this time.
I'd like to take the time to thank you, Scott, for coming out here and showing us how this works. It's awesome. There's no other tool that can do this, especially for sent communication systems. We're going to be seeing a lot more of this. I've heard about this. The first time I heard about this was in 2019, before I ever saw or heard of it ever. Thanks to our friend Ryan Colley over at in the UK. He came by one time and he showed me, hey, are you guys seeing sensors yet? And I had no idea what to tell him. Apparently, BMW was one of the first ones to come out with it. Now we've got Mercedes, we've got GM, we've got Ford coming out with it. We're going to be seeing this a lot more, and I can't tell you how invaluable it is to be able to visualize a communication signal. So thanks again for showing us this demo. I hope you guys see the value of the ADDi system as much as I do. And if you want any more information, where do they find you?
www.automotivediag.com and at automotivediag on Instagram, Facebook, YouTube, and TikTok.
Right on. Thank you all for taking the time to watch. I hope you found this video useful. Catch you on the next one.